All right, problem number 10 is going to require a little bit of a comparison. So when we fire a gun straight up, it gets a height h. Let's also assume that it is fired with a speed v naught. Let's figure out what this height is in terms of v naught, and I'll show you why in a second. So we're going to have v squared equals v naught squared plus 2gh to kind of simplify the equation we get on the AP exam. And I know the final speed is 0 at the top, and this g would actually be negative since gravity acts downwards. So what I'm getting is that when I fire the cannon vertically, the height is expressed as this weird looking thing here. Just go with me on this. Now what's going to happen next is let's now launch at an angle of 45 degrees. And the vertical component of the speed is now v naught sine of 45. So what does that do? In our new situation, we're going to have 0, because v squared is 0 at the top, equals v naught sine of 45 squared plus 2 times the negative g times the new height. And when I solve for the new height, that's going to actually be v naught, and the sine of 45 is the square root of 1/2. That's a weird way of writing it, so that when I square it, I'm going to end up getting v naught squared times 1/2 over 2g equals my new height. So the ratio of the height is actually going to be half of the original height when we solve. I wish I had a good explanation as to how I knew how to take that approach to the problem. The truth is, this is quite a bit of what the AP is. We're going to be practicing more and more of this as the year goes on. Really, your best bet is to do these problems, practice them, and then, when they kind of show up again on exams, you kind of know what to do. Just saying. Hint, hint. Okay, that wasn't very subtle. And then number 11. Here, it says the equation is given by this. We want to know when the net force is 0. So let's be clear. Net force, F is ma, or F is md squared x dt squared. So if I can figure out when the acceleration, which is d squared x dt squared equals 0, then I've solved the problem. So x dot, the first derivative, is 3t squared minus 12t plus 9. The second derivative is going to be 6t minus 12. We'll set that equal to 0 to figure out the time when it happens. That happens when t is 2 seconds. Awesome. All right, number 12, sorry. I think I'm going to need to take a look at this in the next